Hello there. Today, we are looking at the mind map of the chapter, Hydrogen. This is the ninth chapter of the chemistry syllabus for students of grade 11 Cbse. Let's go! So this is the mind map that we are going to be working on. Mind maps basically helps you to revise chapters which you have learned in a short span of time. It also helps you to remember stuff easily by connecting things in a pictorial way. Now this is a huge mind map and has a lot of information. Therefore, we'll divide this into many sections. First, I'll explain the tree, and then all the boxes will be expanded to you, and then I'll explain them again. So, in the chapter, Hydrogen, we'll be first looking at the electronic configuration of hydrogen. We have some pretty cool facts about hydrogen because of its electronic configuration. We next move on to the properties of hydrogen and the isotopes of hydrogen. Next, we move on to dihydrogen, which is the way that hydrogen exists in nature, its most common form, H2. Now we'll look at its preparation, commercial method, physical properties, and chemical properties, as well as uses. Okay, so we'll learn a lot about dihydrogen. So after dihydrogen, we will move towards hydrides. Now in here, we'll look at the types of hydrides. Now after hydrides, we will move on to water, that is H2O. In here, we'll look at physical properties, structure, chemical properties, and temporary and permanent hardness of water. After looking into water, we will move on to H2O2, which stands for hydrogen peroxide. We will look at the properties of hydrogen peroxide, its uses, and above all, its preparation. So after dealing with hydrogen peroxide, we will move on to the final topic, which is heavy water. We will look at its preparation and its uses. So that would be the basis on which what I'm going to talk about in this video. So let's move on to the first part here, that is electronic configuration. Now, the electronic configuration of hydrogen is 1s1. You might have studied this in your earlier lectures. Now, what is the great thing about hydrogen having the electronic configuration 1s1? Well, because of this electronic configuration, it is the first element in your periodic table, the table that has 118 elements till date. Now, because of this electronic configuration 1s1, there has been a very huge debate regarding the positioning of hydrogen in the periodic table. The debate was whether hydrogen was more similar to alkali metals or halogens. With alkali metals, hydrogen has the similarity of its outer electronic configuration, meaning there's only one electron in the outermost shell, and it's forming unipositive ions, such as H+, which is similar to Na+, Li+, K+, etc. On the other hand, it forms uninegative ions as well, since it only has one electron. It can acquire another one to form an H-, such as Cl- and F- does. And it also has a very high ionization enthalpy, which is characteristic of halogens. Now, because of these reasons, hydrogen now has its own place in the periodic table. So these facts are a consequence of the electronic configuration of hydrogen, which, as I repeat, is 1s1. Now, let's move on to the properties of hydrogen. The first property says that hydrogen is similar to alkali metals. Now, in this case, we notice that the three compounds HCl, NaCl, and KCl are equal in the way that the first element possesses a single positive charge. Hydrogen is H plus in its ionic form in this compound. Sodium is also Na plus, and potassium is also Na plus. Now they lose one electron to form unipositive ions, which is the case in these three compounds. The second property of hydrogen is that it's similar to halogens. Now the compounds here will demonstrate why. H2, F2, Cl2. Now these elements gain one electron to form uninegative ion. Since hydrogen only needs a duplet to complete its electronic configuration to a more stable electronic configuration, it can either do an H plus and exist as a proton, or it can be H minus and exist in the configuration of helium, that is 1s2. So with that respect, it can form H minus ions the same way that fluorine forms F minus and chlorine forms Cl minus ions. The third thing here says that hydrogen forms oxides, halides, and sulfides. Hydrogen forms oxides such as H2O. It forms halides such as HCl, and it forms sulfides. The fourth point here is that hydrogen has a very high ionization enthalpy. This is a very characteristic property of hydrogen, and it leads to hydrogen being used as a fuel. It can be used as a fuel, and many scientists have been working on that concept. The fifth point here says that hydrogen does not possess metallic characters under normal conditions, because in normal conditions, hydrogen exists as dihydrogen, or H2, which is more similar to halogens, which are nonmetals. The sixth point here states that hydrogen forms diatomic molecules. Now, examples for diatomic molecules are sodium hydride, or NaH, and hydrochloric acid, or HCl. These only contain two atoms, therefore they are known as diatomic molecules. Now, from the properties of hydrogen, we will move on to the isotopes of hydrogen. Hydrogen exists in three isotopes. The most common isotope is protium. Now, protium has one proton and one electron. Therefore, its mass number is 1. Now, protium is found 99.985% of the hydrogen reserves in the universe. So protium is the predominant form of hydrogen. The second form is also very important. It's named deuterium, and it has one proton and one neutron in its nucleus, making its mass number 2. Deuterium is used in analyzing many of the common reactions involving hydrogen, and is also used as heavy water in nuclear reactors. We'll come back to that. Now, tritium is the radioactive isotope of hydrogen. It has 2 neutrons and 1 proton in its nucleus, and its concentration is 10 raised to minus 15%, which is very, very low. Deuterium, by the way, has 0.0156% percentage as its abundance in the universe. So with regards to protium, deuterium and tritium have very low concentrations. Now, we're done with electronic configuration, properties, and isotopes of hydrogen. Now, we'll move on to dihydrogen. Now, dihydrogen is represented as H2, and it is the most abundant form of hydrogen in the universe. This gas is found in stars, where it is used in nuclear fusion to be converted into helium. Now, the preparation of hydrogen or dihydrogen has many methods. In the laboratory, the most common method would be to react it with the zinc granules. So dihydrogen reacting with zinc forms zinc ions and hydrogen gas. The second method uses NaOH. So zinc granules reacting with NaOH gives sodium zincate and hydrogen gas. Now these are the two methods which in a laboratory would give you adequate amounts of H2. But these methods are not useful when creating mass quantities of hydrogen. Hydrogen is a very useful element in its H2 form. So in H2 form, the first commercial method is to electrolyze water. So water under electrolysis gives two hydrogen atoms, two hydrogen molecules, and an oxygen molecule. Now the second method of commercially producing hydrogen gas is by electrolyzing warm aqueous barium hydroxide, which is BaOH twice. So we electrolyze a warm solution of BaOH twice between nickel electrodes to get dihydrogen. The third method is known as reaction of H2O on coke. Now coke is a form of carbon. So in this reaction, an alkane plus water gives you carbon monoxide and hydrogen. Now carbon monoxide and hydrogen as a mixture is called water gas. Now the next method is coal gasification. So we take coal and we use steam. So we react coal with steam under a very high temperature, that is 1270 Kelvin, to produce water gas from which we can extract dihydrogen. The next reaction is water gas shift reaction. So in this reaction, carbon monoxide from water gas is reacted with steam to get CO2, that is carbon dioxide, and dihydrogen. So these are the commercial methods by which we can produce dihydrogen. Now let's move on to the physical properties of dihydrogen. Now, the first property is that dihydrogen is colorless, odorless, tasteless, and combustible. So that's the reason why when you need to find out whether dihydrogen has been formed, we put a matchstick over the reaction, and if it burns with a pop sound, we will know that dihydrogen had been produced because dihydrogen is combustible. The second point, the second property says that dihydrogen is lighter than air and insoluble in water. Dihydrogen is lighter than air, and it was the reason why dihydrogen was used earlier in hot air balloons. But at that time, the combustible property of dihydrogen led to a lot of accidents, and today helium is used for the purpose. Now, chemical properties of dihydrogen. Now the first reaction says dihydrogen plus X2 gives 2HX. Now X can be F, Cl, Br, and I. So this is the formation of halides. Now hydrogen can form halides using this reaction. The second reaction is the formation of water. Now it states that two molecules of dihydrogen and one molecule of oxygen under a catalyst or by heating gives you two molecules of water. The enthalpy for this reaction is minus 285.9 kilojoule per mole. Now this value indicates that this reaction is exothermic. Now the next reaction is the formation of ammonia. 3H2 plus N2. Now 3 molecules of dihydrogen and 1 molecule of dinitrogen under 633 degrees Kelvin, 200 atms of pressure, and iron as a catalyst gives you 2 molecules of ammonia, which is NH3. Again, we have received the ionization, the enthalpy of this reaction. The enthalpy here is minus 92.6 kilojoule per mole. The next reaction is the reaction of dihydrogen with alkali metals. So H2 plus 2Na plus 2M gives 2MH3. So M can be any alkali metal such as sodium, potassium, etc. So when we react dihydrogen with an alkali metal, we form its hydride. Now, the next reaction says that hydrogen with palladium gives will reduce palladium. Now, Pd2 plus gives us after the reaction Pd. So palladium has been reduced while dihydrogen had been oxidized. So this reaction states that dihydrogen is a reducing agent. Now, H2 plus CO plus RCH double bond CH2 gives you RCH2, RCH2, CHO. So this states that dihydrogen has been used to form aldehydes. And this aldehydes has been used to form methanol. Now, we move on to the uses of dihydrogen. The first use is the synthesis of ammonia, that is NH3. The second use is in the manufacture of vanaspati fat, which we commonly call as dalda. The third use of dihydrogen is in the manufacture of bulk organic chemicals, predominantly methanol. The fourth use of dihydrogen is for the manufacture of metal hydrides, such as NaH. The fifth use of dihydrogen is for the preparation of HCl. Hydrogen chloride can be converted to hydrochloric acid in its aqueous form, and it's been very useful in our school labs and in factories in general. Now, dihydrogen had been used in metallurgical processes. It is a very good reducing agent. And dihydrogen had been used as a rocket fuel. Now, in rockets, we use liquid dihydrogen with liquid oxygen to fire the rocket into the sky at great speeds. And dihydrogen had been finally used in fuel cells. It is also used in welding, as the combustion of dihydrogen gives you a very high temperature. Now, from dihydrogen, we move on to the hydrides section of the chapter hydrogen. Now, hydrogen forms hydrides in three types. The three types of hydrides are: the first type is ionic, saline, or salt-like. Now, these type of hydrides are formed when stoichiometric compounds of dihydrogen are formed with S-block elements. The examples of these are sodium hydride and lithium hydride, NaH and LiH. The second type of hydride is covalent or molecular. The formation of molecular compounds from dihydrogen and p-block elements constitute covalent or molecular hydrides. The examples for these are CH4, that is methane, NH3, ammonia, H2O, water, etc. Now, these compounds can either be Lewis acids or Lewis bases, or they can just be having the adequate number of electrons. Lewis acid needs electrons and Lewis base gives electrons. The third type of hydride is metallic, aka non-stoichiometric or interstitial. Now, these kind of hydrides are formed by D block and F block elements, and they are always deficient in hydrogen. Some examples are lanthanum hydride, which is LaH 2.87, palladium hydride or PDH 0.6 to 0.8, etc. Now, with that, we've completed hydrides. Now, let's move on to one of the most important aspects of hydrogen and one of its most important compounds. H2O, aka water. Now, our human body contains about 65% of water. In each cell, we have about 65 to 80% of water, and in some living plant cells, this can reach up to 95%. Now, this shows that water is pretty important for our existence. Now, the physical properties of water are: first, water is colorless and tasteless. Water, as we know it, is usually colorless, and it does not have a characteristic taste. The second physical property is that water has the presence of extensive H bonding. Now, because of this, we find that water droplets are always circular. This is because of surface tension caused by extensive hydrogen bonding between water molecules in the liquid state. The third point states that water has a high freezing point, high boiling point, high heat of vaporization, and high heat of fusion. Now, this is because of the unique properties of hydrogen when reacting with oxygen, such as dielectric strength, etc. Now, we'll move on to the structure of water. Now, in gaseous state, the distance between a hydrogen and oxygen molecule in water is 95.7 picometers, and the angle between two of these bonds is 104.5 degrees. Now, this is due to the two lone pairs of oxygen. Now, during ice, it is found that one oxygen molecule of water will have a tetrahedral arrangement with 4 other oxygen atoms of water. Now, ice forms a lattice-like structure, and therefore ice is less dense than water. Now, we move on to the chemical properties of water. The first reaction says that H2O plus ammonia, water plus ammonia, gives you OH minus ions and ammonium ions. Now, this states that water is of an amphoteric nature. It can act as an acid in a certain situation and as a base in another situation. The second and third reaction states that water can also do redox reactions. It is a good reducing and oxidizing agent. Now, in the first equation, the second equation, water is reduced by sodium to get sodium hydroxide and hydrogen gas. The third equation is the equation for photosynthesis, where again, water is oxidized. Now, the last equation states that potassium oxide plus water gives you phosphorus oxide plus water gives you phosphoric acid. Now, this is an equation for the hydrolysis constant. Now, we'll move on to the difference between hard water and soft water. Now, hard water does not give lather with soap, whereas soft water gives lather easily. The formation of bubbles when you wash your hands is dependent on this factor. So if while you're washing, you get a lot of soap bubbles, you're using soft water. And if not, you're using hard water. Now, we will move on to the two types of hardness, which is temporary hardness and permanent hardness. Temporary hardness is caused by the presence of carbonates of magnesium and calcium. Magnesium and calcium hydrogen carbonates gives temporary hardness of water. Now, there are two ways by which we can remove temporary hardness of water. The first is by boiling temporarily hard water. Now, a reaction here states that magnesium hydrogen carbonate, while heating, gives you magnesium hydroxide and carbon dioxide. Now, this erases the temporary hardness of water. This is the boiling method of removing temporary hardness. The second method is called Clark's method. Now, it uses the hydroxide of the element which is present in the hard water to form carbonates and water. Now, this also removes the temporary hardness of water. An example here states that calcium bicarbonate plus calcium hydroxide gives you calcium carbonate and water. Now that is how you remove temporary hardness of water. Now, what about permanent hardness of water? Permanent hardness is due to the presence of soluble salts of magnesium and calcium in the form of chlorides and sulfates. Now these are much worse and they can persist for a long time. So therefore, they need to be removed forcefully. Now, the first method of doing this is by using sodium carbonate or soda. Now, the reaction here is calcium chloride plus sodium carbonate gives calcium carbonate plus common salt, which is NaCl. Now the next is MgSO4, magnesium sulfate, plus sodium carbonate gives you magnesium carbonate and sodium sulfate. Now these are the two ways in which sodium carbonate removes the permanent hardness of water. The second is known as Calgon's method. Now Calgon's method uses zeolite, that is sodium aluminum silicate, to remove the permanent hardness of water. The other methods in use are ion exchange method and synthetic resins method. Now that completes our portion regarding water. So now, from water, we move on to the next important compound of hydrogen, which is H2O2, hydrogen peroxide. The preparation of hydrogen peroxide is by three methods. The first method is using barium hydroxide and reacting it with sulfuric acid to give you hydrogen peroxide. The second method uses acidified sulfate solutions, which when electrolyzed gives you peroxodisulfate, which on further oxidation and reduction gives you acidified sulfate solution and hydrogen peroxide. The last method is the auto-oxidation of 2-alkyl anthraquinols. The example given here is 2-ethyl anthraquinol, which when subjected to oxygen and hydrogen gas as well as palladium as catalyst gives you hydrogen peroxide and another oxidized product. Now, the properties of H2O2 are, the physical properties are, the first property states that hydrogen peroxide is colorless and miscible with water. Now, if you have observed H2O2, it will be either colorless or a pale blue color, and it can react, now it can mix with water in any concentration. Now, there is no difference as in what amount of H2O2 you should apply to water to mix it. It can be of any amount. The structure of H2O2 is non-planar. Now, imagine that you open a book. Now, the shape that we get by opening a book is the exact same shape in which an H2O2 molecule is present, either in gaseous form or in solid form. Now we move on to the chemical properties of H2O2. The first reaction, PBS plus 4H2O2 giving PbSO4 plus 4H2O, is the oxidizing property of H2O2 in an acidic medium. The second reaction states the reaction is that hydroxychloride plus H2O2 gives hydronium ions, which is equivalent to H plus ions, plus chlorine ions and oxygen gas. Now this is the reducing capability of H2O2 in an acidic medium. Now the third reaction, which uses manganese ions to give you OH minus ions, is the oxidation capability of H2O2 in a basic medium. And the last reaction here, which is I2 plus H2O2, iodine and hydrogen peroxide, along with hydroxide ions, giving iodine ions, iodide ions, and water, and oxygen is the reducing capability of H2O2 in a basic medium. Now, another interesting thing about H2O2 is that it decomposes on exposure to sunlight. So therefore, H2O2 is stored in wax-lined containers in dark places. And in order to stabilize H2O2, sometimes urea is used as well. Now we move on to the uses of hydrogen peroxide. Firstly, hydrogen peroxide is used as a hair bleach and disinfectant. A common product in the market called perhydrol is an example. Hydrogen peroxide is also used to manufacture chemicals used in detergents, such as sodium perborate. Hydrogen peroxide in industries is used as a bleaching agent. It is used as such in textile industries, paper pulp, leathers, oils, fats, etc. Now, in environmental chemistry, hydrogen peroxide is used in pollution control of domestic and industrial effluents, such as the oxidation of cyanide and aerobic conditions in sewage. So these are the uses of H2O2 that help our planet in staying green. Now we'll study more about this in the chapter Environmental Chemistry. So let's move on from H2O2 to the final topic of this chapter, heavy water. Heavy water is also known as D2O, which is the equivalent of H2O, but it only has deuterium in place of hydrogen. Now, to prepare water using deuterium or heavy water, we use exhaustive electrolysis of water, so in which we replace H plus with D plus, and thus we get D2O. Now, there are two uses of D2O that we should be knowing about. The first is as a moderator in nuclear reactions. Now, in a nuclear reaction, in nuclear fission, electrons move at blinding speed. So when you use heavy water, you moderate their speed so that the reaction stays controlled. The second use of deuterium is in exchange reactions for the study of reaction mechanisms. So suppose we need to look at the reaction mechanism for the formation of water. So instead of using normal water, we use a mixture of normal water and heavy water for the experiment. Now by this, we will understand the pathways that hydrogen follows. Now, that completes this chapter. This is a very important chapter, and we hope this video helped you to simplify it for your boards and to some extent your NEET and JEE exams. Did it help you? What more do you want to see? Please tell us your views in the comments section below. Do like the video if it was great. That gives us more support, by the way. And please subscribe to our channel, Brain Blitz Audios, for getting more useful content such as stories, poems, mind maps, etc. Until next time, have a nice day.